All right. What we have here is we're going to be solving some equations involving logarithms. A lot of students sometimes have problems in doing these, so we're going to try going through these. First off, um, example number one. Whenever you have a log expression, you want to get rid of the logarithm by using the exponential. So we have exponentiated. But before we do that, the first thing we want to do is we want to make sure that we combine these. Or you can rearrange it so we can have a log on both sides. So I guess it all depends on how you want to approach this. One thing that I would probably start out with doing is I might just actually take, and in this problem, take natural log of 3x plus 4, and I'm going to add actually this other one to the other side because what I can then use is a one-to-one property. Now I have natural log on this side, this side. If I e both sides, boom, cancel. Cancel using inverse operations. Now I have 3x plus 4. That's going to equal 2x plus 1. And that's what we got right there. Now from here, all we're going to do is we're going to solve this. When we solve it, we're simply just going to subtract 2x both sides, subtract 2x both sides, and what subtract that is, it's going to be x plus 4, it's going to equal 1, and x is going to equal, what do we got here? Subtract that, it's going to equal negative 3. All right, it appears that x is going to equal negative 3. Now you have to be a little careful because whenever you have logs, all right, you always have to check to make sure they work. So test this out. I just want to just make sure I did everything correctly when I did that. Yep. Okay, 3x, subtract that, 5. I think I did everything good. All right, now I'm going to check this. If I plug this back in here, I have the natural log of 3 times negative 3 plus 4. All right, and then I can do the same thing to the other one, natural log of 2 times negative 3 plus 1. I don't want to get too much over here because I'm going to be doing another problem a bit. And what we have then is negative 9 plus 4, the natural log, and that's going to turn to negative 5 natural log. Uh-oh. Hopefully you know that you cannot take the natural log of a negative number. You can't take a log of a negative number because remember, logs are exponents. If you ever learned this, um, the exponent of the base, which is e, will never equal negative 5. So this one does not work. Therefore, guess what? That doesn't work. And you see the same thing will happen over here. We'll get a negative 1. That won't work. So yeah, there is no solution. No solution for this problem, unfortunately. All right, and that's how we can see this algebraically. If you graph this and test this out, you would never have a y-intercept, or sorry, x-intercept, and it wouldn't be solved. So I guess that was, great, I guess. Not really cool, but whatever. So next one, we have log of x minus 1 equals log of x minus 1 times log of x plus 2. So let's see if we can figure this one out. Now this one's a little bit different, this one, because we don't have just have a 0. We can't just add this one to the other side because we have two logs. Now, a lot of people would say, okay, just so you know, when you just have just a log of x, this is actually a common log. It's a base 10. Just want to make sure everybody knows that. So we can try to 10 it, but we have to combine these first. Now, this is the problem where we have to combine things first. So we're going to have log of x minus 1. And I'm going to actually use the properties of logs. And whenever you're adding a log with the same base, you actually can write it as a log of x minus 1 times quantity x plus 2. All right, so I'm actually multiplying those two. Now, when we have this, I'm now going to 10 it. All right, so we have x minus 1. That's going to equal x minus 1 times x plus 2. All right, I guess, well, whatever. All right, so now we have this right here. Now from here, we can simplify this. You might notice that we have these two. We probably can simplify this some way, somehow. Let's see if this works out. We're going to take this right here. I see that these two actually are the same. I guess I noticed over here. I could probably subtract those two. I could get 0 right away. Well, I didn't realize that right away. But I'm going to actually, I'm going to just see what we got here. I'm going to factor it through. just to find out. So we have a plus x, and that's going to be a minus 2. That's going to be x minus 1, just to see and make sure I don't lose any of these other values. I'm going to subtract x, so that's going to cancel out. Subtract x, that cancels out. And I'm going to add the 2 to the other side. So I have 1 equals x squared. 1 equals x squared. All right, when I have 1 equals x squared, what's going to happen is take the square root. And when I take the square root, get a plus and a minus. And what we have is possible solutions of positive or negative 1. Now, once again, we have to test this out. Well, if I plug in 1 in here, can you have log of 1 minus 1, which equals 0? Can I have a log of a 0? So now I'm testing this just so everybody knows where I'm going here. All right, use a color testing this out here. I'm plugging the 1, positive 1, into this expression right here. Well, 1 minus 1 is log of 0. Can you do that? No, you cannot. So we can't plug in the positive 1. Plug in the negative 1, we can see that will be a negative. Can't have a log of negative 2, so that doesn't work out. Holy cow, none of these work out. That is horrible. All right, well, let's try something else here. All right, yeah. Well, that was kind of uneventful, wasn't it? Let's do one other one. I'm going to just kind of make one up here because I think this is going to work out a little bit nicer. We're going to do a third example because I want to show you that this actually, we actually can get a solution for some of these. I'm going to take this example. The natural log of 7 minus x. I'm going to take that one. I'm going to take a plus natural log, and we're going to have 3x plus 5. And that's going to equal the natural log of 24x. All right, we got that right there. Now, in looking at this, we're going to go through and we're going to solve this. So now to solve this one, once again, this one is a lot different than the other two. All right, this one we probably could have subtracted the other side and got something when it worked out. But here, we can't really subtract anything. We can't bring anything to the other side. So yes, actually using private logs and combining these is the number one thing we have to do right away. So we're going to take this. I'm going to use a different color so we can see what we're doing here. Change it up a little bit. Natural log. Whenever you're adding two logs of the same base, you can combine them into one argument, like so. That equals the natural log of 24x. We got that. Once we got this, we now realize we have the same. We can use the 1-1 property, or we can e both sides. And what happens is the inverse relations cancel them out, and we're left with the values inside. Now from here, we're going to do a little bit of, all right, multiplication. So we got this, we got 21x, we have a 35. Following this through, we got negative 3x. It's going to be negative 5x. That equals 24x. From here, we can simplify this a little bit farther. All right, let's check this one out. I'm going to actually add 3x to the squared x to the other side. We're going to take these two and I'm going to combine those. All right. Shouldn't get too much of a mess right now. Well, it actually, I'm going to subtract that to the other side. So what I'm going to get is 3x, and that's going to equal, and subtract the 35 to the other side. And then I'm just left with this lonely little 5x right there. And then what I'm going to do is I'm going to add that to the other side. So then we have 0 equals 3x squared. It's going to be plus 8x minus 35. Minus 35. Now from here, what we can do is we can simplify this. All right, we can simplify this and see if we can find an answer and see if this is factorable. And actually, I think this one is factorable. All right, right here. So let's see, because it is a quadratic. We could also use the quadratic formula or put this in our calculator. But I believe what we have here is going to be, let's see if this works out. 3x, what do we got? 3x, and we're going to have an x here, and what are the factors of that we can get. And let's think of this as, we go plus 5. Let's make this negative. We'll go -7. And then we'll go right here, we'll go +5 there. Let's see if this works out. All right, so that's a negative, just so everybody knows. We have 3x, so it'll be 3x squared. The middle terms we're going to have is -7x, and it's going to be 15 and 15. All right, 15 minus 7 is going to be 8x. Hey, I think we did it, yay. So what do you find out right here? We have x is going to equal 7/3 and -5. Okay, well, once again, we have to check this out. If you remember our last two problems, we got no solutions, so um, let's find out if this works out. So we take our -7/3, we have to plug it back into our negative. All right, so let me just take these, borrow you, and we'll just move you up here. All right, so I'm going to take 7/3 and plug in there. That turns to be okay. That's okay. That's okay. So -7/3 is actually, hey, we got an answer. This one is a-okay in my book, so that one's good. Now, when we plug in -5, that one's good. Uh-oh. When you plug in -5 here, all right, -5 times 3 is -15, plus 5 is going to be -10. You need to get a log of a negative number? No, you cannot, and therefore that one will not work. But we do get an answer and a solution of x equaling 7/3. That would be one of our answers. So when you're dealing with logs, you have to combine them and exponentiate them to solve them. At times, you need to test your answer because at times you can get no solution, as we did in our first two problems. However, if you do have the right problem, all right, you can factor it, all right, use the product exponents to combine them, bring them together, use E to get rid of the logs, always combine them first, all right, then E. And from here, you can simplify it, and if you're lucky, get a nice factor, and you can get an answer like this. All right, so we went through 3 different problems of using logs and how to solve them. I hope this helps you out in solving some additional problems in the future. All right, good luck and God bless.